Any problem?
Just stop.
Half an hour and then just stop.
Yeah, I think it's in the program. Thanks for highlighting it. Okay, this is an important point. So based upon the number of design lanes, we have multiple presence factor M. We multiply this factor by the loads. We use this factor to increase the loads or to decrease the loads. You know why? Because if, for example, you have a bridge in which there is just one lane only, everything is passing. For example, it's a bridge and this bridge has just one lane. Have you seen such bridge?
تمام.
Where?
عارف المكان ده اللي جاي كذا when you go to أحسن.
Between
As a
Bahrain and
curve.
Dammam.
Yes, you're right. Okay, there are many in fact. One lane. So in that case, either it is a truck. You can go somewhere. You wanted to go there? Okay. So one lane. If it is a one-lane bridge, the traffic has to pass on this lane in any case. The traffic should have to pass because there is no other choice. Do you understand or not?
Yes.
If it's a truck, big truck, it has to pass by this. But if your bridge has 4 lanes, then what about the location of your truck? It could be here, it could be here, and if the truck is here in between, so it could be also here. Do you understand?
Yes.
No, not only here, also I have seen the same thing maybe in Kuwait and also in Qatar, but in UAE little bit better. But I think the same in Oman and also in the rest of the world. If you go from there to Iran, to Pakistan, to India,
Go to Egypt.
yeah, Egypt also the same. But from North and South Korea, it changes. I mean, they have very strict rules. South Korea, and then Japan, then Australia, New Zealand. Okay, but this most of the Asia, you can find a truck here. Okay, so for example, the truck could be anywhere. So in order to calculate the loads or the number of loaded lanes, now you have a probability. Probability is that the truck could be perfectly on this lane, here, here, or anywhere. Now, but the total width of the bridge is very far. It is just like a live load. For example, if you have a small area and you have a shore live load, so you will consider the full live load or even the more. But if you have a larger area, in that case, the live load could be anywhere. Okay, so if you have more number of lanes, your multiple presence factor is less, so you are reducing the force effects. But if it is just one lane, it is 1.2, very high, because you need more factor of safety. Do you understand?
Yes.
We will use this lane factor, and if it is more than, why it is less than 1? Because if you consider equal to 1, and there are 4 lanes, now I think it's not justified. You are not considering an economical design consideration. Okay, now how much is a live load? This is the important thing for us. Well, in the previous Astro design codes, there was a truck which is known as HS20, and even there were more types of loading. HS20, HL93. HL93 is the most recent one. It was developed in 1993 in the revised Astro condition. So that is why this HL93 is basically, because it was revised in 1993. So that is why we call it HL93. But some people, they are still using HS20. These values are based upon the Astro design code. But if you go to some other country, maybe in Europe, they have their own bridge design codes. Okay? So in that case, their loading name would be totally separate, because here we are mainly following the American design codes, so that's why we are talking about HL93 and HS20. Okay. So what is HL93? In HL93 we have how many types of load? Number 1, truck. Number 2, design tandem, and number 3, design link. So we consider 3 types of load in case of HL93. It is an important point because we will consider all these 3 design loads in our design. For example, what is HL93 loading? Let me tell you, HL93 loading has 3 parts. Number 1, design truck. Number 2, design tandem. What is tandem? What is tandem?
The two vertical loads
Yeah.
that have the same
2 wheels which have 2 axles combined together, which have the same loads,
Yeah.
wheel loads. Number 3,
design lane.
design lane. Okay, now what is truck load? HL93 truck. I'm going to show you this truck load. This is the standard truck. You cannot find this truck on the road maybe, because it is some idealized truck which is used for the design. But if you design your truck based upon it, it satisfied most of the criteria. Now what is this truck? I've shown you the same truck in the H2. So please see and don't forget. How I will show this loading? When I will do the examples, I will show this loading something like this. This is 35, 145 kilonewton, and this is,
Space.
I will use 4.3 meter most of the time. This is the wheel 1, wheel 2, wheel 3. I will show like this, or the opposite way. For example, in that case the truck is moving this way. But if I show this way, can you see? But if I show 35, 145, what does it mean?
The opposite
That is
direction.
The truck is moving
To the opposite
to the
direction.
opposite direction. Okay? And this is one, this 35 is for the full axle. This is the axle load. This is not the wheel load. This is the, so how much will be the wheel load? Half of this. For example, if the axle load is 145, so this axle load is this, 145. How much will be the wheel load?
72.5.
Yes, 72.5, 72.5. Remember this. Okay. Okay, any question about this truck? Now, tandem. So, what is a tandem load? Tandem load, if you read the definition, in case of tandem, the width is same. For example, in case of tandem, now, this is how I show the tandem load, 110 kilonewton, and the distance between these two axles in case of tandem, if I remember correctly, is 1.2 meter. I'm not sure. Yeah, it's 1.2 meter. In case of truck, it is 4.3. You can adjust this distance based upon your requirement. It should be between 4.3 to 9 meter. You can consider any distance of your own choice, which gives you the critical force effect. This is 1.2 meter, 110 kilonewton, 110 kilonewton. This is in the elevation. But if you see in the cross section the tandem load, it will look like this. But the only difference is that now this load is how much? 110. And the width is 1.8 meter. These distances are very important for us because we have a 3 meter lane. So where to put the truck? Do you understand or not? You should have these distances in order to calculate the forces. And we will use lever rule. Most of the time we will use lever rule. And in order to draw the influence line diagram, I taught influence line diagram, I remember. You took structural analysis with me? Structural analysis you took with me? I teach or not?
Yes.
Influence, I'm asking from him. Did I teach?
Yes.
Okay. Yes, Bisma. Did I teach? So, do you remember what is absolute maximum bending moment?
Absolute maximum.
Yeah.
I didn't take it to you, but I remember.
Absolute maximum. I taught that.
When you change the location until you get there.
The maximum bending moment. So, in order to calculate the absolute maximum bending moment, we need these distances. I will teach you. I will give you a little bit revision of influence line diagram. Don't worry. Okay. Okay. Now the third thing. Please silent. Now you know what is design truck. You know this. Now you know what is tandem. Now the lane. What is lane load?
So,
Anything other than the truck and tandem is lane load. Now it could be your car, it could be you, it could be your small bike, it could be your big car, it could be a delivery truck. So everything comes in this. And how much is the value? For example, if the width of design lane is 3 meter, and this is the intensity given by the ASHTO, 3.1 Newton per square meter. How much is this load? 3.1 Newton per meter square. Kilonewton or Newton? Kilonewton, sorry. 3.1. So in order to calculate, for example, how this lane load is acting, please see here. These are your lanes. Okay? And this is the width of the lane. How much you want?
And 3 meters. 3 meters.
It depends. You should be having this width because it depends upon the geometry of your bridge. And this geometry is given by the traffic. Do you understand or not? I mean, this is known thing. Known. So how much is that? For example, just you can take it 3.6 or 3.1, what you want.
3.6.
Okay, 3.6. For example. Uh, 3.6. Or in this case, it is taken how much?
3 meters.
Yeah,
3 meters.
3. So how you can calculate? This is the load per unit area is 3.1. So how you can calculate the load per unit length?
3.1.
So your lane load will be acting like this. If you multiply by this width, this will be your lane load. Do you understand or not?
Yeah.
And this value is 9.3 Newton, kilonewton per meter. One last thing about the loads. In these two loads, we take a dynamic effect. We take a dynamic allowance. What we do, we multiply these loads by 1.33. For example, because truck and tandem, they have impact. They have impact on the expansion joints. You know, there is an impact. So in order to consider that impact, we multiply these two by 1.33, and it is known as dynamic allowance. What we call it? But in case of lane, there is no dynamic allowance. There is no dynamic allowance. Okay. Now, please see. These values are taken. These values are taken from the ASTO, and it gives you the allowable deflection under live load. This gives you the allowable deflection under the live loads. For example, how you can calculate the allowable deflection under a live load? If your girder is 30 meter, and for this case, how much will be the allowable deflection? No pedestrian. In this case, there is no pedestrians. So 30 meter divided by 800. If the pedestrians are also present, if the pedestrian load is also present with or without these three loads, so in that case it is 1000, and then how much will be?
317 something.
30 meter over 1000. So how much is allowed?
1000. 10 something.
10 centimeter. Now just imagine 10 centimeter. How much is that? Something like this.
Yes.
Still, it is very high limit. It gives you vibration. It gives you vibration. So for a good design, it should be less than 10 millimeter or 20 millimeter. Because it's too much. 10 centimeter in a bridge is too much. But again, the span is also 30 meter. 30 meter span is very big span. Don't think it is small.
How much is 30 meter or how? You said
30 meter. So it will be how much?
No, it's different. I think it's 100 meter.
Okay, how much is that? 30 meter over 1000.
It will be 3 centi, I think.
Yes.
3 centi. Yeah.
3 centi.
It makes sense.
It's 3 centi.
It makes sense. This is what I was considering, thinking.
Yes.
Do you understand? So 30 centi, yeah, it should be like that. But that one, okay. So, for example, once you have how to calculate deflection, you know. I suppose you already know this by what? By default. You have studied it in structural analysis. Okay. This table, again, we are looking at this table. This table gives us the minimum depth of a beam. I explained you this table. This table is from Astro Design Code. The first, it gives you the depth of slab. It is just like H minimum in case of slab, H minimum in case of beam. I told you, for example, if the length of beam is 30 meter, then how much should be the depth of beam? 30 multiplied by 0.07. Something around how much? 2.1 meter? I'm not sure.
30.
Okay, whatever. I'm now very weak in calculations because I don't want to go in the calculations. Okay. So this table gives you, just put that span, you will get the required depth. It's so simple. Okay, and that's a trial depth. All these depths are trial depths. For example, if you get like a depth, if you get like 691.5, Will you use exactly that value?
No.
No, you should round up to the reasonable value. Like if it is 691.75, I will use 750. Okay, multiple of 75 mm. Minimum depth, I just told you, minimum overhang thickness is 200 mm and 300 mm for side mounted post system, and 200 mm in case it supports concrete parapets or barriers. So this is the minimum thickness of, for example, the slab thickness and the overhang. What is overhang? Overhang is this part. This part is overhang. Okay. At overhang we give the higher depth, the minimum reinforcement ratios. Please put yourself on silent. Okay, minimum cover to the reinforcement. This table gives you the minimum cover, as you have the minimum cover in case of reinforced concrete. Like for beam, it was 40 mm. Do you remember? And for column, it was again 40 mm. For slab, it was 20 mm. But here, in case of bridges, you have these values of the minimum cover. Okay, if you have bridges in the water, or if anything like foundation or some slab, if it is in the water or in the earth, you should use these two values as the minimum cover. Okay, these loads. From here I will start in the next lecture. I'm not going to tell you these loads. I told you these loads in the Astro. Just read. Mainly in this course we will be considering which load?
Did that lie?
This DC and then DW. We will not consider any earth pressure, we will not consider any earth surcharge, we will not consider any vertical pressure due to earth fill, we will not consider any braking force, centrifugal force, any creep, any collision, any earthquake, any friction, any ice, but IM, we will consider this IM. This is 1.33. How we will consider? Just multiply by 1.33. And LL. And what we consider? Live load. This live load is from these three, HL93. We will also consider PL in some cases, pedestrian load. We will not consider any shrinkage. We will not consider any settlement. And for your information, these loads, what we are going to consider are the most critical load on the bridges. So you should not worry. You should not worry that why you did not consider the collision force, why you did not consider the braking force. Because these forces are there, but they are very minor. Okay, compared to the real live loads. Okay, these are also some pedestrian load is this, like lane load. Lane load is, how much was the lane load? 3100 Pascal or 3.1, but in case of pedestrian it is 3.6 kilopascal or 3.6. How you consider, for example, you want to consider a pedestrian live load, so you should multiply the width by 3.6, sorry, this length, the width of footpath by 3.6 to get load per unit length. So this concludes this class, and from next class we will talk about design. Do you have any question?